So our next objective, to determine whether samples of convenience are acceptable. So that last case when you went to the mall to sample people, that was actually a sample of convenience. So in some cases, it's difficult or impossible to draw a sample in a simply random way. So, like trying to get everybody in your township, to like try to randomly sample everybody, that can be difficult because it's hard to go walking down every street, trying to contact people, going door to door. You're probably missing people. There's a lot of things that would be difficult with it. And it would be much easier to just go to the mall and sample people. May not be the best way, but it's an easier way to do this. In these cases, the best that one can do is to sample items by some convenient method. So I always think of convenient sampling as kind of like your lazy sampling. You're not trying very hard. You're trying to do this in the quickest and easiest way possible. So like going to the mall to poll people instead of trying to go door to door. A sample of convenience is a sample that is not drawn by a well-defined random method. There may be some randomness to it, but it's not well-defined. It's probably not simply random either. Typically, convenient samples are collected in a way that is easy and often do not, I just said that, and often are not a simple random sample. So sometimes it's okay to sample with convenience and it's not going to be a problem. In the case of the mall, that was a problem because you're only getting people who go to the mall. That's probably going to sway whether they're more Republican or more Democrat. Maybe not, but there's a good chance it might. And also, if you pick a mall, if you have a big enough town, you might have a mall that's in more Democratic region, and you're going to get more Democrats in that mall, or a mall that's in more Republican region, and you're going to get more Republicans in that mall. So there's a lot that is wrong with that previous one with the mall that is going to cause problems with that convenient sample. So just take a minute and think about this one. Decide if you think that this convenient sampling is actually a problem or not. A construction engineer has just received a shipment of 1,000 concrete blocks delivered in a large pile. So they just come, pile your blocks and go. The engineer here wishes to investigate the crushing strength by measuring the strengths of a sample of 10 blocks. Explain why it might be difficult to draw a simple random sample. And then we're going to talk about whether it's a problem. So, like I said, take a minute and think about this. Why would it be hard to do a simple random sample with blocks? And also, is it going to make a difference if I do a convenient sampling and just say, grab the first 10 off the top? Okay, this is why people don't like statistics here, because this is kind of opinion based a little bit. So it might be difficult to draw a simply random sample of blocks, partly because the blocks are heavy and they're in a big pile. So the problem would be that the blocks are heavy. You got one structural engineer here trying to test some blocks. Blocks are heavy. And we would like need to label each block to make a random sample. And then we'd have to select them randomly. They'd probably use like a number generator. So the biggest part, like I said, is those blocks are heavy. So he's got 1,000 blocks. Imagine you had to take those 1,000 blocks, lay them out flat. Then you had to go through, number each and every block. Then you'd have to go get a random number generator. Then you'd have to go find those 10 blocks out of them and go take them. This is a whole lot of work to do. So that's why this is going to be really difficult. Because for one thing, some of those blocks, if he's trying to randomly sample it and they're in a big pile, are going to be the bottom of his pile. So the next part of this would be, is just grabbing 10 blocks off the top, is that going to be a problem? It's definitely a sample of convenience, and it's definitely not going to be simply random. But is it going to be a problem? Like with the mall being a problem, is that you're basically skewing your results by going to the mall because you're excluding certain people. But the blocks are a little different. So really, this should not be a problem. Because the groupings of blocks, there's nothing that's going to make certain blocks better than other blocks. And that's because the blocks should be the same if they're on the top or the bottom. So the blocks should be the same no matter where they are in the pile. Because when you're making cement blocks, they're being constructed in a way where the blocks are supposed to be similar to each other. So those blocks should, for the most part, be similar. So, and when they throw them there, I'm pretty sure they didn't do it in some sort of way where they organized those blocks. They just took a heap of blocks, dumped them there, went away. So this shouldn't be a problem. Like I said, it's not simply random, but this should be an okay way to sample in this case because those 10 blocks at the top should be the same as the 10 blocks in the middle or 10 blocks in the bottom. They should all relatively be the same kind of block. So because of that uniformity of the blocks, the sample of convenience is not an issue. So problems you may have with samples of convenience, which we were already talking about, is that samples of convenience, the samples that you collect may differ systematically in some way from the population. So like I was saying, when you have that big pile of blocks, and I pick some of them up here, there's not really anything that should be systematically different from these blocks than these blocks. However, when you're going to that mall, you're trying to sample from this town, maybe your town looks like this. Maybe that mall is located in the Democratic part in town. So if I select people of convenience here, I may be avoiding these people because they're probably less likely to come across town to go to this mall. And there could be a mall over here for them that's just closer. This mall might be next to a school. And the hospital might be in this part of town. So once again, people who live over here are probably going to be more people who are going to be working in a hospital, and people here are more likely to be working in a school. That is going to be something that could have an impact on your study about politics as well, as depending on where they work. So this is what we mean. There may be a systematical difference from these populations. So I'm focusing on those people in the mall. I'm avoiding all those people who don't live near the mall. Or I may be avoiding all those people who just don't have a reason to go to the mall. So it is reasonable to believe that no important systematic difference exists. If there's reason to believe there's no important systematic differences, then it's acceptable to treat a sample of convenience as if it was simply random. That's what we're talking about with those blocks. There's no reason to believe that these blocks are different from these blocks. Therefore, I could treat that sample like it's simply random. So just another example. Clearly, this one's going to be the one with the problem. A local store, a grocery store, wants to poll customers about their shopping experience. They decide to poll the first 20 customers who enter the store. Explain why this is not acceptable, why it is not acceptable to treat the sample of convenience as if it were a random sample. If you want, you can take a minute and pause and think about that. So what we're looking at here is that when we decide to pull the first 20 customers in the store, you're talking about the really early birds. That's what you're sampling here. You're sampling the early birds. So there's other shoppers you can have. But what we're looking for is primarily, is there going to be a difference from this group of people who are your first 20 who come in? Are they going to be different from everyone else? And like I said, if you're thinking about that concept of the early birds, these are the first people who walk into the store. The people who are going to be first into the store, let's like say the store opens up maybe like 8 a.m. So you probably don't have people who work first shift. So people who are in this first sample probably do not work first shift. If you have a, trying to think, it's third shift, I think would be coming in later. The shoppers would probably be coming in as time would probably be third shift workers. Trying to think, it's been a long time since I worked in a grocery store. I'm trying to remember who came in at what time. But your third shift workers are more likely to be in this time because that's when they're around. Um, you're more likely to have, like, if you're looking at parents, you're more likely to have a stay-at-home parent. Is more likely to come in and they're early. They're not as likely to come in. The other shoppers, however, one of the things they would probably have is more of your working parents. So this is the kind of things we're looking for. It's like, what varies these? Is there a difference between these two groups of people? Once again, older populations tend to go to the stores early and things like that. So you're more likely to get your more elderly population. You're more likely to have younger customers at this time. Younger customers will come in later in the day. They might be coming in at 3 o'clock, but they're more likely to come in later in the day. There, I'm going to put first shift here, not third shift. So these are the kind of things that we're looking for. Is there a difference between these groups? And people who would come in, your first 20 customers in the store are going to be different than the rest of the customers you have, because the people who work first shift, they're probably not going to be at the store first thing in the morning. People who are working, parents, are not going to be the first ones there in the morning. Your stay-at-home parents are more likely to be there, which is going to have a difference about the kind of money these people are going to have as well. So there's a lot of things that's going to cascade from that. Your stay-at-home parents and your working parents are going to have different incomes from each other, more than likely. So that is another thing to worry about. Think about your elderly customers and your younger customers. Elderly are more likely to be there in the morning, and your younger customers, because they're working, are more likely to be there later. So in this case, I would say no, it is not acceptable to treat this population or treat the sample as a simple random sample, because it is not everybody has equal chance of being chosen. There is going to be a definite difference between these two groups of people as well.